Hi. In this set we have there are 15 girls and some boys among the graduating students in a class. They are planning a get together which can either be a 1-day event or a 2-day event or a 3-day event. Now there are 6 singers in the class, 4 of them are boys. There are 10 dancers in the class, 4 of them are girls. So if there are 6 singers out of which 4 of them are boys, that means the remaining 2 will be girls. And out of the 10 dancers, if 4 of them are girls, 6 of them will be boys. No dancer in the class is a singer. So these 10 dancers are separate from these 6 singers. Now some students are not interested in attending the get together event. Those students who are interested in attending a 3-day event are also interested in attending a 2-day event, and those who are interested in attending a 2-day event are also interested in attending a 1-day event. Okay, so let's make a table for this. We know there are total 15 girls. Out of 15 girls, 6 singers are there in the class, 4 of them are boys. So 4 are boys singers, that means the remaining 2 will be female singers. Out of the 10 dancers in the class, 4 of them are girls. So out of dancers, 4 of them are girls, that means the remaining 6 will be boys. And we know there are total 15 girls in the class. So out of 15 girls, 4 are dancers, 2 are singers. So 4 plus 2 is 6. Hence 15 minus 6 is 9. So 9 of them are neither dancers nor singers. Right? Similarly, we have among boys, 6 are dancers, 4 are singers. Let's say a number of boys who are neither dancers nor singers is x. So the total number of boys that we have is 10 plus x. Okay. Now there is some additional information given as to who is interested in a 1-day event, 2-day event and a 3-day event. So we have all the girls and 80% of the boys are interested in attending a 1-day event. All these girls are interested in 1-day event. 80% of the boys, 80% is 4/5. 4/5 of boys, which is 10 plus x, are interested in attending a 1-day event. Fine. Now it's given that anyone who is interested in attending a 3-day event is also interested in attending a 2-day event, and anyone interested in a 2-day event is also interested in a 1-day event. So anyone who is interested in 2-day event is also interested in 1-day event automatically. So there can be no one who is interested in only a 2-day event but not a 1-day event. Those kind of people will not be there. So this number here should definitely be less than 15. It cannot be more than 15. If let's say this is anyway, this total is 15, but in any case, let's say if out of these 9 people, 5 are interested in 1-day event. So this number here cannot be more than 5. It has to be less than 5. It cannot be 6. If 6 of them are interested in a 2-day event, all these 6 must also be interested in a 1-day event. So this number could not have been lower than this number. Similarly, this number here cannot be lower than this number. This number will definitely be less than 6. If this is 6, this number here will definitely be less than 6. So we'll see that again when it is required. And it is also given that 60% of the boys are interested in attending a 2-day event. So 60% of the boys, that means 3/5 of 10 plus x. So 3/5 of 10 plus x. These are the number of boys interested in a 2-day event. Next, some of the girls are interested in attending a 1-day event but not a 2-day event. So out of these 15, some of them are not interested in a 2-day event. So this number is definitely less than 15. Whatever this number is, let's say t, this is definitely less than 15. And some of the other girls are interested and definitely greater than 0. Some of them are interested in a 2-day event, but not all of these are interested in a 2-day event. So this number t here is definitely going to be greater than 0, but definitely less than 15. Fine. Now 70% of the boys who are interested in attending a 2-day event are neither singers nor dancers. So 70% of these are neither singers nor dancers. So 70% of these will be 7/10. Let me write this value here is 70%. That means 7/10 of 3/5 of 10 plus x, right? So this is basically 7 into 3, 21 by 50. 21 by 50 times of 10 plus x here. Okay. Next, 70% are interested in a 2-day event are neither singers nor dancers, and 60% of the girls who are interested in attending a 2-day event. So we are talking about 60% of this. So 60% of those girls who are interested in a 2-day event are neither singers nor dancers. So 60% of this is 3/5 of t. 60% is basically 3/5. So 3/5 of this is neither singers nor dancers. Now no girl is interested in a 3-day event. In 3-day event there is no girl interested. That means all of these must be 0. Some of these would be the total, right? If total itself is 0, all of these will be 0. All male singers and 2 dancers are interested in attending a 3-day event. All male singers, so singers, all of them, 4 of them are interested in a 3-day event, and 2 of the dancers out of the 6, 2 of them are interested in a 3-day event. Now if all 4 are interested in a 3-day event, all these 4 must also be interested in a 4-day event, because it is given that anyone who is interested in a 3-day event is also interested in a 2-day event, right? And similarly, all those who are interested in a 2-day event are also interested in a 1-day event. So this number here must be greater than or equal to 4, but it cannot be greater than 4. So hence it will be equal to 4. And by same logic, this must also be 4 over here. Okay? Fine. And then you have number of singers interested in attending a 2-day event. Number of singers interested in a 2-day event. That is sum of these two. We are talking about singers, not just male or not just females, total singers. These two together is 1 more than the number of dancers interested in attending a 2-day event. So number of dancers will be these two. So these two together is 1 more than these two together. Okay. So there are a lot of unknowns here, so we'll come back to this point again. Let's say this value here is A. Okay. Now if this is A, we know A plus 4 plus this should be equal to this thing. Or rather, we knew this number is 70%, right? This number is 70% of the total. So these two together should be 30% of the total, right? Total is this. So number of boys who are dancers and singers and who are interested in a 2-day event, which is A plus 4, is simply 30%, that is 3/10 of the total number of boys, which is 3/5 of 10 plus x. Okay. So from here we have A plus 4 should be equal to 9 by 50th of, how much will it be? 10 plus x. Okay. Now A plus 4, this left hand side is definitely an integer. A has to be an integer. So the right hand side here should also be an integer, right? Now for right hand side to be an integer, 9 is not divisible by 50. So 10 plus x should be divisible by 50. Now for 10 plus x to be divisible by 50, this 10 plus x should be either 50 or 100 or 150 and so on. So assuming if 10 plus x is 50, then we get A plus 4 is equal to 50 by 50 is 9. Hence A comes out to be 5 here. Okay. Now is A 5 fine? Yes, A should be greater than or equal to 2 but less than or equal to 6. So A can be 5. No problem. So if we have 10 plus x as 10 plus x as 50, A comes out to be 5. If we have 10 plus x as 100, then A plus 4 will be 100 by 50 is 2, 2 into 9 is 18, so A comes out to be 14. But A cannot be greater than 6, right? so this is rejected. Similarly, further higher values of 10 plus x will give us higher values of a, which will not be accepted. So the only possible value of a that is acceptable is 5. So a is 5 over here, and we get 10 plus x is 50. That means x must be 40. X here is equal to 40. So the total number of boys that we have is 6 plus 4 10, 10 plus 40 is 50, right? So this becomes, if total number of boys is 50, number of boys interested in a one-day event is 80% of 50. So 80% of 50 is 40, and total number of boys interested in a 2-day event is 60% of the boys. 60% of 50 is 30, and boys who are neither singers nor dancers interested in a 2-day event is 70% of 30, which is 21, right? So 5 plus 4 is 9, 9 plus 21 is 30, which matches the data given, right? Now the only thing remaining is to figure out what is the value of t over here. Okay. Now we were given that the number of singers total interested in a 2-day event is 1 more than the number of dancers interested in a 2-day event, right? So assume that this is A. So the number of singers interested is A plus 4, and this is 1 more than the number of dancers interested. So let's say this is D. So number of dancers is D plus 5. Okay. So from here we get D is equal to A, 5 plus 1 is 6, 4 minus 6 is A minus 2. So if this is A, this comes out to be A minus 2 over here, right? Now think about it. What is the possible value of A? A cannot be greater than 2, but this has to be a non-negative number, right? So here it says A has to be greater than or equal to 2. A can be the 2, 3, 4 and so on, but A cannot be greater than 2. So the only possible value A can take is 2. So this is 2 and this will be 0, right? 2 minus 2 is 0. Fine. Now it's given that of all the girls interested in a 2-day event, 3/5 of them are neither singers nor dancers. That effectively means that 2/5 of them will be dancers and singers combined. So 0 plus 2 combined is 2, which is equal to 2/5 of T, right? So from here T comes out to be 5. If T is 5, this comes out to be 3 and T is 5. So this is 5, 3/5 of this is 3 and the remaining 2/5 is this over here. Okay. Now if this is 2, then this must definitely be 2, right? Achha, it's given that all the girls are interested in a 1-day event, right? So this will be 4 and this will be 9. All of them are interested in a 1-day event. It was already given, right? Now the final thing remaining here is to figure out these two values and this value. Okay, let's see. Now this value here has to be greater than or equal to 5, correct? So it can be either 5 or it can be 6. We are not sure what will it be. So if it is 5, 5 plus 4 is 9 and 40 minus 9 is 31. So in that case, if this is 5, this must be 31. Or if this is 6, 6 plus 4 is 10, 40 minus 10 is 30. This will be 30 then. And this value here must definitely be less than or equal to 21. This is the only, as in we have pretty much figured out the whole table except these 3 blocks. Now let us look at the questions. So the first question is, how many boys are there in the class? So we knew x is 40, so total number of boys is 50. So the answer here is 50. Next, which of the following can be determined from the given information? First statement, number of boys who are interested in attending a 1-day event and are neither dancers nor singers. So 1-day event, neither dancer nor singers. Can we determine this? No, it can be either 31 or 30, so we cannot be sure about them. So we cannot determine this number uniquely. Second, the number of female dancers interested in attending a 1-day event. Female dancers interested in a one-day event is 4. So this was actually pretty much given in the question already. So we can only determine the second statement and not the first statement. So only 2 will be the right answer here. Okay. Next, what fraction of the class was interested in a 2-day event? So in a 2-day event, a total of 5 plus 30, 35 students were interested out of total strength of 15 plus 50, 65. So fraction of the class interested in a 2-day event is 35:65. This goes by 5 7 times, this goes by 5 13 times. So 7 by 13th of the class is interested in a 2-day event. Option C is the right answer. Next question, what best can be concluded about the number of male dancers who are interested in a 1-day event? Male dancers interested in a 1-day event can be either 5 or it can be 6. Hence option A is the right answer. Okay. And finally coming to the last question, how many female dancers are interested in a 2-day event? The female dancers in a 2-day event is 0. So the answer here is option A, 0. So that's it for the set. Thank you.